Okay, so today we're going to be talking about how to make a position versus time graph given a velocity versus time graph. Now, if you're watching these videos on the same day or if you're watching them chronologically, you may be confused. You may think to yourself, hey, didn't you just make a video about this? No, I did not. We did, in the previous video, we did going from position time graph to a velocity time graph. This is how to go backwards. And in the last video, I kind of lied when I said that was one of the hardest things in the courses. In my opinion, this is even harder. Okay, so it would be a good thing if you took some time, did your due diligence, and actually practiced a few of these. Okay, this should be useful for your stacks of kinematic curves worksheet. All right, so I'll start this one like last time, reminding you that the graphical definition of instantaneous velocity is as follows. The slope of a tangent line of a position versus time graph at a given point gives you the instantaneous velocity at that point in time. So what I'm talking about here is if I were to find the slope of this blue line here at this point in time where I'm drawing this black mark here, what that would tell me, or what the slope of that line would tell me, is how fast that object is going here. Okay, likewise, if I wanted to go a few moments later in time, right, notice how my dotted line has moved forward, so it's later in time. I have a steeper blue line, so that just means it's going faster. Also note that both lines are positive in slope, so we can tell that the object is moving in the positive direction. Okay, going backwards. So this is kind of interesting because it's kind of like a puzzle, okay, and we need to just fill in the blanks. So first up, we know that our first velocity is 0, and we know that our second, or our final velocity rather, is negative. So we know that during the whole course of travel that this object is moving backwards, okay? And we also know that, again, its initial velocity is 0 by our first dot, and then we've also got a very negative velocity here. So this is all about going backwards. Think, how does that translate to a position versus time graph? Okay, well, first off, we know that it's going backwards. So can we first agree that if something's going backwards, we've got a position versus time graph that will start here at some greater position. And we also know that our position versus time graph should end somewhere here. Okay, right? That's moving backwards. Certainly is moving backwards. You start at the greater position and you start at the position of 0. That's moving backwards. Now, we need to know how this line is going to curve. Again, this unit's all about curved position versus time graphs. So first up, we want to make sure that our tangent line has a slope of 0. Okay, 0 meters per second to be exact. So our first tangent line at time 0 has to be horizontal. Okay, and we also have a clue that our next tangent line has to be negative and very steep. Okay, so negative and very steep for me looks like this at that point in time. So you want to think, what looks like this? Okay, well, if I were to do that, there's only really one shape that would make this work. Okay, so I'm going to switch to red here, and if you notice that I tried to go like this, that would not work because that does not look like a tangent line, nor does this. Okay, so we cannot have that. All right, we want to make sure that we have tangent lines. So let's try the other curve. Instead of a sideways upside down opening, we're going to go with a downwards opening parabola. And yes, that certainly works. Okay, so that would give us a position versus time graph that matches with this velocity time graph here. Okay. Okay, next up, we're going to go a little bit faster through these ones. Okay, this is just a matter of practice, so do not get discouraged if you're not picking up. Just rewatch the video and try some more. We'll try this one together. First up, velocity versus time graph. What's it doing in the beginning? What's it doing at the end? First up, we've got a velocity of 0. So again, that means that the first line should have a slope of 0 meters per second. And then we've also got a positive velocity. So that means it should be steep. The tangent line has to be steep and it has to be positive. Okay? Which direction is it moving? Well, everything is taking place in the positive quadrant. So we know that it has to be moving forward. So the way we're going to do this is I'm going to place my first 2 dots. Here are our clues. I know it's moving forward, so I'm going to place one in a less position and one in a greater position. Simple enough. Okay. And I'm going from a slope of 0 initially. Looks like a horizontal line to me. Right? It's the only line with a slope of 0. And I want something with a positive slope and is steep. So something that's steep and positive looks like this to me. Okay. So I'm going to make a shape that will match so that it makes sure that these are still tangent lines. So we're going to go like this. Oh, wait. Sorry. No good. We're going to go with, there you go. Okay, so those are tangent lines. Okay, next example. Hopefully this is, kind of settling in. Let's try this one. Velocity versus time graph looks like this. Okay, we can kind of tell stuff about its motion. We know it's slowing down. And we also know that's moving in the positive direction because the curve is in the positive region. That's fine. What does a position versus time graph look like for something that's slowing down while moving forward? Well, first up, we know that's moving forward. So its position versus time graph should start somewhere here and end somewhere here. Okay? And then we've got our tangent lines. So first up, we've got a velocity that's positive, and it's also very steep. Okay, and we end with a velocity of 0 because the slope is 0. Rather, we have to draw a tangent line with a slope of 0 because its velocity is 0. So for the first line, we have to draw something that's positive. It's got a tangent line that's very steep and very positive. And then we've got a tangent line with a slope of 0. So we want to think to ourselves, whoops, what line fits this in such a way that these lines are still tangent lines? Okay, so we want to make sure that it just grazes the tangent lines like this, grazes again, and there we go. There's your position versus time graph for this. Now, what's important to note is one thing I didn't bring up in the last 2 examples is that if we have a velocity versus time graph, we don't know what the initial position is. So if it's not specified, the initial position is whatever you want. Okay, so what that means is if you like, you could have drawn this like this, or you could have drawn this down here if you want it to be weird. That's fine. These are all acceptable shape. As long as the shape is the same, I would have to accept this as a right answer. Okay. Next. All right, so in this one, I'm gonna let you pause the video for a moment and try on your own. Okay. How'd that work out? Let's see. So first up, we've got a velocity versus time graph, right? We know it's negative here because it's below the time axis. And we know it's got to be steep because it's far away, right? And let's look at how it ends up. Seems like it ends up with a velocity of 0. So I know the tangent line that I have to draw has to have a slope of 0 meters per second. All right. So first up, which direction is it moving? Forward or is it backwards? Now this is a confusing one. I've had previous students, the common misconception on this one is that it's moving forward because the line's going up. Well, you have to be careful about that because it's fine that it's moving up, but that doesn't mean it's moving forward. We have to remember that this region here is a negative region. So that means anything that's happening here means that the object's moving backwards. Okay, so it's moving in a negative direction. So I'm going to draw my first point somewhere high here. And then my last point is going to be somewhere low here. Right? That shows something that's moving backwards if it starts at a high position and ends at a low position. Okay? Now, I want a tangent line that's very steep and negative to start. Looks like this to me. That certainly is steep, and that certainly is a negatively sloped line. And I also have I want to make sure that I end with a line that's horizontal because the slope's 0. And then think to yourself, okay, what kind of graph makes this shape? Okay, well, first I've got this tangent line. We want to make sure it's a tangent line. None of this, right? Can't do that. Crashes right through. Not good. Not very good. We want to make sure that it's a tangent line by definition and by look. So it just grazes. So that's what it could look like. It's actually a sideways opening parabola, but upside down. And that's when you're slowing down and moving in the negative direction. So there are 4 different shapes, all right? So again, you want to practice this. I would like for you to not memorize this, even though you technically could, but it would make me happier and it would be better for your learning if you learned how to go through this procedure yourself, okay? So practice on these. Ask questions in class, and then we'll talk about it later, okay? Bye.